Okay.
Hi, Juan Cruz.
Hello.
Are you there?
Yeah,
Yeah.
I'm here. I'm here. Yeah, we are again here with another workshop, the
Yeah.
fifth one,
It's been a
right?
long time.
Yeah, it's been a long time. Like 3 weeks ago was the last one. Maybe
Yeah,
one
I think
month.
so. Yeah. Yeah,
Yeah, we were
almost. Yeah.
in. We were at Mendoza for the last one, or was it? Yeah, I don't remember
Yeah.
exactly.
The last one was in Mendoza. Oh, was it? I don't remember, but I think it was a long time ago.
Yeah, long time ago. Okay, so what news have been happening for the past month? I guess that we can just talk about the last week ones. I believe there was something with Twitter, right? And Elon Musk.
There was a lot of stuff going on, like always on AI, but what happened in Twitter that Elon Musk decided that he didn't want to feed all the LLM models with his tweets, so he
Yeah,
limited the access to scrapping and almost users to, I think, 300 tweets per day per person, and if you have a blue mark, 800 or something like that. But it's crazy. I mean, like he's trying to change the way the app works based on uh, his he doesn't want to share the tweets to train LLMs. I mean, I get where he's coming from, but he's totally ruining the app, I think.
yeah. I mean, 300 tweets is really small, a small amount,
Mhm.
and I believe that if you do a search, you waste like 20 tweets, and then another search is 20 tweets more. So yeah, that application is going to be really uh, short
In
in
fact,
the
I think that Zuckerberg Meta, I mean, came out with
yeah,
an app like in the last day. I don't remember the name. That is like Twitter, but by Meta.
yeah, yeah, exactly. And apparently that application doesn't have a website. It only works on mobile. That's something weird. Yeah.
Oh, mhm.
So yeah, for
No,
some
I
reason
haven't
they
used it,
didn't
so I
implement
don't
a
know.
website.
Yeah,
Yeah,
I really don't
and
know. I just use Twitter to like see people fight. That's my use of Twitter.
okay. And there was another news that I thought that it was interesting that a new paper came out by MIT that they
Mhm.
evaluated GPT-4 with some MIT math tests, and the evaluation way that they used it was really weird because they said that GPT-4 can score 100% of MIT CS curriculum exams or questions,
Mhm.
but they were using GPT-4 to evaluate those answers, and they just checked against the API until they got the right answer. So that will be just the same as if you had a student and you will ask the same question until they have the right answer. So really weird, right? Like,
So what's the conclusion there? What was the conclusion?
no, I mean,
So GPT-4 knows everything. That's the conclusion.
yeah, apparently they say that it can answer any questions of these MIT exams, but yeah, I mean, with infinite time, you could answer just by randomly throwing words at it, right?
Okay, it's
So
like
yeah,
the infinite monkeys with infinite machines writing Shakespeare.
exactly. Yeah, exactly. That it's the same thing, and yeah, Microsoft wrote that. No, sorry, MIT wrote that paper, and it's really weird. But yeah, I guess
Maybe
that makes you think on all the other papers where they are evaluating LLMs, what
mhm.
kind of evaluation are they doing? Because I don't know if I really dive really deep in the way that they were evaluating the models. So yeah, that's worth checking out right now because
Yeah, I think it's quite an important field to this evaluation because at the bottom, if you just ask an LLM to evaluate other LLMs, we really don't know what's going on there.
yeah, exactly. Yeah, we need to check our benchmarks.
Mhm. Yeah.
So yeah, let's jump to today's workshop. I guess it's all yours since you prepare
Okay.
this.
Okay. Just let's go with sharing my screen with my beautiful collab. Okay, guys. So this workshop it's about embeddings and memory. why embeddings and why use it to give memory to a chatbot? It's because first we have to talk about what is an embedding, right? An embedding is like a mathematical representation of a word, of a phrase, of a picture, of whatever, on a matrix space, like a vectorial space. You have whatever you want to represent converted to numbers. But those numbers are not a direct representation of the word, of the phrase, or whatever. It represents not only the word, but the context that word is. So if whatever you have like a word like elephant, we are going to trade later, and maybe you have like the phrase, the elephant is in the jungle, the amount of dimensions that the representation is going to have are the same. It doesn't matter if one is a word and one is a phrase. That gives us the possibility to work with those embeddings and use those embeddings to search with context. Like if you have a lot of embeddings stored, you can search like for the nearest representation of that embedding that you're searching for. So if you want to search for elephant, you're going to get everything related to elephant, not only the word. And that embedding depends on the embedding algorithm that you're using. So there are lots, and there are paid ones. OpenAI has its own embedding algorithm. There are open ones. There are lots. You have to search for the one that works best for your application. So let's dive in.
Fede, these embedding algorithms, are they algorithms or are there some kind of model that you have to train?
No, it's an embedding algorithm, but it's a model. You have to train those embedding algorithms.
Okay.
All of the embedding algorithms that I use, I didn't train them. You can train an algorithm, but it's not really like the most important part if you want to work in a project using embeddings. So you can use directly the one from OpenAI, or I'm going to show right now another one from TensorFlow it works really fine. It's not so good as the OpenAI one, but you can use it anyway. So let's dive in.
Yeah. So sorry for interrupting, but the idea is summarizing a bit is that this thing apparently is some kind of function that transform some kind of text into a vector, right? So an array of numbers, a floating point numbers that represent that text. So then instead of comparing text against one another, what you compare are vectors, and then somehow you use that vector and then retrieve the text again, right?
Exactly. You use a vector math, so you can compare like the nearest one in a vector space. So that search, it's better than like a regular query on an SQL database, because you have to know what you're querying for. In this case, I don't know what I'm querying for. I know that I want to search for this, and I don't know the nearest one and how to search it. Just a mathematical comparison, and that's better because you probably don't have the same words on the thing you're querying and the answer you get from the query. That's really important. But you have to think that not only you can embed a text, you can embed images, you can embed audio, you can embed whatever. In this case, these algorithms that I'm using are for text, but there are others that work for other kind of information.
Okay, perfect. Got it.
Okay, so let's start working here. First of all, I'm going to import a lot of libraries here. There are probably a lot of one that everybody knows. TensorFlow is like a really important one on machine learning. But the one that I want to take first here is ChromaDB, and the other one, Chroma. This is the database that I'm going to use to store those embeddings. There are databases that has this vector operation inside. The one most known right now is Pinecone, but there are other ones. This Chroma works exactly in memory, so this is going to be used right now. I'm not going to store on disk, but there are others like Postgres has like an extension non-PG vector, and there are other ones. There are a lot. I'm going to just use this one because it's easy to use in memory and it works very good. So first of all, I'm going to load this universal sentence encoder. Is an embedding model from TensorFlow. It's free. You can use it whenever you want. and creates a function that just call this model, the one that I'm loading in memory, and giving an input text, it's going to return the embedding, the vectorial space, the vector representation. That's just simple as that. And here I'm going to use later I'm going to use the embedding model from OpenAI that's called a text embedding ADA 0.2, and I'm going to use ChatGPT as always as a model because it's the fastest one, the cheapest one, the best one. And that's it. So the first part, I'm going to embed a word, elephant, and a sentence. In a sentence of which I would like to get embedded is a regular sentence, and I'm going to show that even though that this is a word and this is a sentence, the result of those embeddings have the same size, 512, 512. That means that the representation of this word and the representation of this phrase are 512 floating points number, okay? In this case, the model, the one that I've used, that is Universal Sentence Encoder from TensorFlow, the result is 512 dimensions. The OpenAI one is 1,536 dimension, I think. I don't remember exactly. But this is to show only that no matter what you embed, if it's a word, a sentence, or more than a sentence, you're going to get the same dimensions, so everything can compare to everything. You can compare this word to this phrase, or everything can be compared using vector math. This function, I'm going to just load it because it's a function that I created just to do a heat map from the correlation between the vector spaces of these words that I'm going to embed. I created some words, some phrases related to smartphones. I like my phone is good. Some related to weather, some related to food, and some related to age, right? So when I run this, I'm going to get this heat map. This heat map shows the correlation between one number, right? In this case, I like my phone, the vector space of I like my phone, and all the other ones. So in this case, the red, if it's super red, is super related, like it's one is like the most relationship of all. So this one with the same, obviously super related, or always diagonal is the relationship between the phrase and itself. And you can see that this block are the three related to phones. There's another block here, another block here, and another block here. As you can see, the one that are more related, the colors are more red, are the ones that had the word phone inside and the word age, or how is super related. On the other ones, they are related, so you can see that the color is like slightly over yellow, but not super related. But maybe you can see that if I change here, maybe it's raining.
I mean, for example, there you are comparing those two that are kind of related and they don't share the same words. Like an apple a day keeps the doctors away. If you compare it with eating strawberries, it seems like it has some correlation there. And yeah, I mean, it makes sense, right?
There is correlation because they are talking about fruit, but it's not super intense because they don't share the same word.
Exactly.
Like I'm going to change this phrase on weather. It's raining and my phone will get rain, and we'll see how the color, you can see all this got redder. So the space related to phone got more relationship because I had the word phone. This doesn't mean that you have to use the same word, just to show that the relationship is more strong because it has the same words.
I want to check something. Can you change phone in that one, in the raining one, for I don't know, my communication device, for example? Just to check if it's about meaning or just about words?
No, it's
Okay.
it's more related. It's not super
Yeah.
related because it doesn't have the word, but as you can see, it's more related that here are these yellow ones that are slightly more yellow. But
Yeah.
you can see that communication device is more related to phone than rain.
Yeah, and
So
also
if I can,
it's more related to my phone is not good, right? Like
Mhm.
if
Yeah,
your phone got ruined, so I mean it has kind of the same meaning. So yeah, makes sense.
exactly. But as you can see, it's super difficult to represent 512 dimensions on a two dimensions that is we can do in a graph. So I'm going to use another example to graph this. I'm going to use PCA. PCA is a method to reduce dimensions. It's a machine learning method. It's implemented on scikit-learn, so I just have to do PCA, the function, and the number of components I want to use, and that's it. I can go deep inside on how this works, but it doesn't relate to this workshop, so I'm going to just use it. So I'm going to embed these words, bee, dog, king, and queen. I'm going to embed it, and I'm going to reduce to 2 dimensions. Now I'm going to plot those 2 dimensions, and we can see in a chart how the words are graphed here. As you can see, king is more related to dog, or more near dog because they seem male, queen more related to bee, and king is near queen. As you can see here with these 4 words, you can see that using these vectors, you can do a really nice clustering because I can do it just by eye here because I can split the screen horizontally and I get the male ones. I can split the screen vertically and I can get the related to king and queen and the animals. And I'm going to just add some word here as an example, maybe wolf, another animal, a simple another one, queen bee, that is related to bees and queen, and some words related to king and queen, but also related to chess. No, let's put rook and bishop. Sorry, get the quotes.
Makes sense.
Let's go with words. Okay, so now you clearly see how these embeddings relate to one another. You get all the animals on maybe on the diagonal. If you put the diagonal just like straight diagonals, you get all the animals on the upper part. And if you get the wolf and the dog are super related because obviously dogs and wolf are related. The words related to chess are also related. King, rook, and bishop are real near each other. You can see here that these embeddings were really good to getting the meaning and the relationships of words. Obviously, these are two-dimensional representations, so it doesn't get everything here, but you can see it by yourself in this picture.
That's amazing. I mean, how you can see the clusters just as simple as that by just contracting. I mean, because you're grabbing all those 512 dimensions and you're just plotting into 2 dimensions, and this is what comes up. So,
using a machine learning algorithm that's called PCA, that's exactly for that, to reduce dimensions. And this is a simple example, and this is probably not super useful, more than showing that you can get meaning and you can get relationship of these embeddings. It's not, you don't, if you use PCA to reduce just to 2 dimension, you're removing a lot of meaning that you don't want to remove. As this is simple example, I use this, but on a more example on production, you're probably not going to use PCA. You're just going to compare the 512 dimensions one another.
Can we do just as one more test? For example, if you add in the word insect or the word mammal, for example, I want to see how they will apply in this chart or this plot.
Let's do it.
Yeah.
So insect, where is insect? Insect is near wolf, dog, and mammal, but insect is also in the left on the left, you have queen B, and insect also.
Towards B, yeah.
And mammal is on the right near wolf and dog, and you can say queen, king, and rook and bishop.
And also
animals.
Queen and king, yeah, they are mammals also. Yeah, makes sense. Yeah, that's amazing.
Yeah, it's super cool, super beautiful to see it like this. It's not super useful, but just nice to see it.
Yeah.
Okay, so let's dive into the chatbot. This is a help function that I use just I can print the text on the screen and like with color and formatting using 80 columns. So not super important. You can later check on the collab I'm going to share. So if you want to see the code, but it's just a helper function. This is the function that gets the response from the OpenAI. I'm just using a temperature of 0.4, but we can change it later to see how it works. It's not super important. And this function just gets a lot of messages, send those messages to OpenAI completion chat, and get the response. That's it. First, we're going to go through a first iteration of the chat. I'm going to start with a system that says you are a creative chef. You like to people to create menus. That's it. That's instruction for the system. And a while true loop here that is going to be a chat. I'm going to insert some text. The chat is going to answer, and that's it. It doesn't have anything fancy here. Hello. Okay, how can I help you? I want a menu for today. Let's see what it says. Menu, okay. I like Indian food. Okay, so simply as that, I'm working with a chatbot. I'm going to stop right now this cell, the execution. I could be accent, and we are going to check the messages. This is all what's going into every call to the LLM is going to insert all this information so that the chat knows what I'm talking about. This is just a regular implementation on how the chat API works. So now that I stop it, maybe if I run it again, it's like starting all over because it doesn't have any memory. It doesn't have anything to store all what I've been using. I can use a regular database to store all this text. That'd be okay. But if I use a regular database, I wouldn't be able to send all the text. If I have like a conversation of, I don't know, 3 hours conversation, it will reach my limit context of tokens. So I need to find a way to store this information in a way that I can search it by meaning and not by just words. So that's where the ChromaDB and the embeddings come around.
Fede, one question. So every time you're running this cell, you're overriding the messages, right? So you lose context. Yes. You lose all the messages that were in the previous chat. So yeah, if I understand, what you are going to do is something like after you finish chatting with this, you're going to embed that chat and later search on it on the database.
What I'm going to do is while I'm chatting, I'm going to be storing everything or every interaction, and I'm going to embed those interactions. And in every interaction, I'm going to search for previous content if it's related to the question in the one that I'm asking now. So let's go there. First of all, I'm going to initiate the ChromaDB. It's as simply as instantiating a client, saying that I'm going to use OpenEmbedded API function, and I'll use an API key and the model that I defined earlier, and then a collection. A collection is just like a database inside the SQL database or whatever. In this case, it's going to be named conversations, and it's going to use this embedding function, like the one of OpenAI.
Fede, this ChromaDB is running on your memory or on the memory of this collab? Oh, okay.
Exactly. When I run this code, it initiates a Chroma client. That's it. And if I close this window, the memory is going to be wiped. So goes away. It doesn't store anything. You can use ChromaDB and store it. It's not what I'm doing right now. It's just from memory.
Okay.
Okay. So we had the same prompt. The message, the starter prompt is the same, but I'm going to be keeping chat of the chat history, the metadata, and some ID, because to store the data in the ChromaDB or in any database, you have to have a unique ID. So I have to create one here. I'm going to keep tabs on that, on this history ID. And this code is the same as before. And here, in every interaction, I'm going to search. I'm going to ask for a input here, and I'm going to use that input to search on all the information that the assistant used to in the previous conversation, in previous iteration, and as it do an embedding query. So if anything related to this new input is on the database, it's going to be here, and I put the top two just because I don't want to get all the documents, just the top two. You can change these parameters. You can use,
You are using the input text that comes on the message that you have in this instance, and then you're filtering all the messages that the assistant gave in previous interactions, and you're keeping just the first two.
Exactly.
And you are filtering by meaning, so by using the embedding.
Exactly. Right? And after that, I'm going to use the result of this. Maybe there are non-document related, maybe there are more, but I'm getting two. So I'm using those and created a user role saying on a previous chat, I had this interaction. This is going to be inserted on the queue of messages for the chat completion.
Yeah.
And after that, once I get the response, I'm going to store this information in the database. I'm going to append on the metadata that I have, that is a user message. I'm going to append the input text. I'm going to then append the assistant, and I'm going to move the contact ID, the current ID, one position, so that I can keep some, and I have a unique ID, right? And after that, I'm going to add this interaction, the metadata, and IDs. I'm just using different lists, or I can, in this case, there are two, but I could be more than just two. Okay, let's see how this works. Hello. I want a menu for next week, let's say. Please add in so year, months. Sorry for the jump. Okay. Let's say I don't like garlic, and I'm allergic to. Sorry for the jump after the enter. Okay, so it gave me a menu here. That's it. No, nothing fancy. I really don't care what we are seeing right now. So I'm going to exit this. And we're going to see what's going on behind the scenes here. First of all, let's check on the messages. This is all this interaction. Right now it wasn't empty, so I can see all the interaction that I was having. This is the last response. And let's do something here. I'm going to run this again. So after I run this, everything's going to be blank except the database. So let's go. Hello. And we are going to ask for something that we talked before. Maybe let's see. Okay. So for this date, we have avocado toast with sliced tomatoes, poached egg, lunch tuna salad, and dinner green shrimp. Let's go. Do you remember? Hopefully this will give us what we want. Okay, avocado toast with fried tomato, tuna salad, and the grilled shrimp with skewers with roasted vegetables.
That's amazing.
This it was just as you saw, all was blank, and this is getting from the memory. I can keep doing this and searching for other meanings. I can keep this conversation. Maybe give me the recipe for the shrimps. Here's a recipe, and maybe I can tell him I don't like oregano. Don't like oregano. Yeah. So let's see what it does. Okay, simply remove the oregano. Okay, that's it. We really don't care about this right now. As you can see, we can access the memory, and the search is going to be done using context. So in this case, I ask for a date. Maybe I can ask for, I don't know, maybe whatever you want to ask in the questions. But I have an idea that I'd like to implement. Maybe we can make it work, is to use another kind of memory. In this case, we have all the iterations of the chat, and we are storing that. I wanted to get some meaning of this, just to reduce what I'm storing, or maybe use it on another way. What I wanted to do is get all the messages from the user. These are all the embedded messages from the user. Hello, I want this menu for this week. I don't like garlic. I want to see if I can get information from this and use that information to create new meaning. In this case, what I'm going to do is get all those messages, the one from the user. I create a new queue of messages that are only from the user, and I'm going to give a new prompt. Please make a summary of my like, dislike analysis, refer me as user, limit the answer to one list of each item. So when I run this, I'm going to get the answer from the LLM. Sure, here's summary of like, dislike. I don't have any likes. I dislike garlic, and I am allergic to peanuts. So I'm going to use this and store this also on the ChromaDB. And this way, I'm going to create memories from the text. In this case, it's a simple one. But the idea is that you can, every certain time or every certain amount of messages, you can use those messages and reduce them by asking the LLM for something that you want to do, as extract important information, create a list or whatever, and you can use that to embed also and keep it on the memory so you can get better results.
Yeah, you could have a parallel agent processing the context of all these chats and be creating memories on the context, right? On these things that you weren't explicit about, you could say.
Exactly. This is just a simple example. The idea here is that you can use this on different memories. You can also create new ones. You can use different databases. You don't have to search. Maybe you can have one database for the chat history, and you can have another one when you store the most important parts, the one that's are being extracted by LLM. You can do whatever you want here. Okay, so let's try this last iteration, adding that to that function that does that. Every certain amount here, I'm going to add, like, I add an ID here. Every five iteration of IDs is going to do that summary. So first, in this case, let's go again with hello. Okay, as I already have like the memory loaded with a lot of memories, the ID was over 5. So when I started, it did the adding. This is here are the user did not provide any information of the likes. Okay, this I add here another memory, and now I can keep on chatting and asking whatever I want of this information is now on the memory. Okay, so let's do it. I need a new. for tomorrow. I like Indian. Okay, as you can see here, there was another interaction, and again, it tried to create a memory. In this case, it's not super good implementation because I'm running just after a certain amount of messages, I'm running the same query. This is better refined, but the idea is that not only you can do memories from the chat, but you can create another memories and insert them and use them during the chat.
Did it add that you liked Indian food there, or didn't? Likes,
I didn't
dislikes?
know. Let's.
Oh, it didn't add
It
it.
was. Let's check it out. Hello again. I don't know if it's going to work. Let's see. Here's some likes.
It added it. Indian food,
Yeah, Indian food. It was because it's not a good implementation. It just first it tries to give you the answer and then insert it so it wasn't printed on the last iteration, but it was
okay.
okay, but this is just an idea. It doesn't mean that it's super good implementation and it's going to work. But the idea is you can use these embeddings to store what you are doing in your chat. And maybe if you have like a chatbot to answer questions, you can use that iteration to extract meaning during the chat conversation with the client. It can every certain amount of time just see, okay, what questions are being asked, what topics are being asked, and maybe create new memories from that. And the next time this person connects to your chatbot, it already knows the most important thing that he wants to talk about. Or if he was talking about the case and got disconnected, you can continue the conversation. There are a lot of things for here to implement on a production environment.
Yeah, I see a lot of interactions. I mean, I would really love to use this. I have a spreadsheet with all my earnings and yeah, and how I use my money. Let's say with my balance, I could use this to process that and see where I'm spending and where I should cut expenses, etc. So yeah, I mean, you could do some kind of processing and then ask the chat if you can actually purchase something and have a virtual financial assistant, let's say. Yeah, I mean, it's pretty powerful. This way of creating memories.
The good thing about these memories are because as on the idea you just had about the maybe a virtual assistant for your money, you can use their like embedding memory just to see if, okay, I want to know what if I ever spend money on I don't know, on the movies. And on that questions you can see theater, movies, whatever. In other words, like you can use for that. And maybe you can also use a regular SQL database here, and so you can mix both. You can use a regular database to store the money you have and all the counts or the balances, and the other one with the memories embedded, so that you can have the best of both worlds.
Yeah, you can structure just the hard data or the relational data in some kind of SQL database, and then have this meaningful or meaning database, let's say, or this vector database with the other kind of information that is harder to track, right? I mean, this is amazing. Yeah, this way of handling the information.
Yeah, another thing that I want to just add here is on the queries. I'm just doing this query using text because that's what I have now. I can also embed the text or the question and use the embedding, send the embedding to the database, use just sending the numbers, and it's going to work. And this where here, I'm filtering over the metadata. As you know here, as you heard, here role is being stored as metadata. So you can also filter with the metadata. Here I just use it the role, but you can use the IDs, or if you have any categories, as you maybe say, okay, these are memories from, I don't know, you can put that on a tag here. It's like any tag, just a JSON, and you can filter on that. It's super easy to use these vector databases. It's like a non-relational database mixed with the embeddings and the vectors, and that gives super good freedom.
I mean, just looking at a little bit on the code, you are tracking those three arrays. One has the IDs, the other the history, and the metadata. Oh, because you are tracking those three fields separately, right? So you have, for example, in one side you have the actual content, and in the other the metadata that is this role.
We can see here. Oh, okay. Well, so let's start a new conversation. Because you maybe we can.
Yeah, it's always clear.
Yeah, maybe you can print it here. Okay, let's do this. So you can see how it's in store.
Yeah, and the chat metadata.
Okay, so this is what I'm seeing here. As you can see, this is the metadata, role user, role assistant, and the other one is hello. Hello, how can I assist you? Is the other parts are the chat history. This is the user, this is the assistant, and we were missing the IDs. The IDs here are just a number that I'm just accumulating.
Like a pointer,
important. Yeah, like I can say something like that. And that's it. That's what I have for today. I hope that I try to make my point here that if you want to use embeddings for not only for LLMs, you have to think embeddings as a powerful tool for maybe clustering and getting insight from different information, and they are super useful, as you can see here, not only for LLMs but to see context or meaning in words.
Yeah, I mean, you can just those plottings that you did at the beginning, right? Those charts are some kind of there are some powerful visualization tools. I mean, you can plot you can plot text with this. So if you have knowledge articles, and let's say that you want to build a knowledge graph on how those articles relate to one another, you could do this. You could just plot this and maybe inspect the data in some kind of vectorial way that is hard to imagine. I mean, if you had to do this with just the words, maybe you can do it, right? But this does it automatically, and you can just process huge data sets, and it's going to be really automatic.
Not only that, you can find like hidden information. Maybe you have like an expert on you have a knowledge base, let's say, and you have an expert on one subject and another expert on another subject, and you want to give him one of them exactly the same amount of articles to work on, and you really don't know which ones begin to go to the other one. So you can use this to cluster all the knowledge articles and say, okay, this one go to this person, this one go to the other person, and maybe the title doesn't give you that information, or you don't have any tag to give you that information. So you can use it for that also.
Yeah, I these tools are really powerful, and we are just starting to see how to use them. And I'm probably going to use these kinds of embeddings in order to apply it to the solution that we did with the Strata on the last workshop, because this is pretty powerful. I mean, we could use that in order to create in order to create, for example, new questions or new questions for the FAK, right? For the frequently asked questions. Yeah, we will keep track of those and create new ones in terms of what is people asking, for example, in the chat.
Yeah, I remember that, and that's what I was thinking about. You can keep all this information and try to relate all the questions on these embeddings to see which questions are more related to one another, and say, let's group all these questions under this group, and let's do a FAQ question from these ones.
Yeah. Okay, Fede, this is amazing. I mean, thank you for this workshop.
Okay.
Let's check the questions in the chat. Maybe we have apparently there isn't any. Javier Zavala is saying that this is really great. So yeah, we are
Thank you.
aligned with that. Okay, so yeah, I guess we are going to see each other again in the next workshop. I do not have it planned yet, but I believe that we can combine this with the previous chatbot and maybe try to do some kind of UI around it. But this is already pretty complete. Yeah, this is pretty complete because you show it with this feature that Colab has, that it can ask for a new line, right? So yeah, you build the chatbot with memory. So
yeah, but it also be good to see on because with the Strata collaboration was like a good way to see something that might get into a production environment, something that is real. This is just for showing. The other one, you can see this, but in a real thing.
Oh, we have a question here. If is there any tool to create embeddings in JavaScript? I mean,
I really have no idea, but I'm not an expert on JavaScript.
No, the embeddings models that we said at the beginning, they are trained models, so they are actually machine learning models. So if you can use them in JavaScript, it's going to be through an API. For example, here Fede is using this model through an API, and also you could use, for example, I don't know, the embedding model from OpenAI through their API. So you can just use it. But
it's
running
just a call to an API. That's it.
Yeah. Running the calculations in JavaScript is going to be pretty weird. Maybe you can do it. Maybe there is something weird over there or outside there. But usually these models run in Python. This is the standard for these models. There are some models actually that you can run on Hugging Face, right, Fede?
Exactly. This one especially is on Torch Hub. That is also a library for machine learning, and everything here is on Python. You can get stuff outside Python, but if you go through the machine learning path, Python is the way.
Yeah. At least for now.
Yeah.
Okay. We don't have any more questions.
On that subject, OpenAI just released the code executor for every user, not just for the ones that got it by luck. So you can be a machine learning expert using just OpenAI to get the data there and everything. It's like really good.
Yeah, the code interpreter is a pretty powerful tool. You can upload files, for example, a CSV or maybe an image, or actually you can upload a video, and it can cut the video. For example, if you ask for just the first 3 seconds, it will do it for you. So yeah, that tool is pretty powerful. I mean, it does the coding of Python for you, and it can even train models there. I mean, if it doesn't need too much processing power or maybe too much memory, you can run pretty complex solutions there.
We are here working with the LLMs that are super advanced NLP models, but the regular models are like a regression, keep on working. In fact, if you need a logarithmic regression or something like that to do a prediction for some value, you can probably train that model on OpenAI, and it's going to be coded on Python, and it's going to be coded by itself and run it on there. It's crazy.
Yeah, it's amazing. Okay. Yeah. So there are no more questions. But we can, I guess, we can end it for today. Thank you again. Let's see each other. Maybe let's hope that it's not maybe in 1 month, but maybe in a few weeks. And yeah, let's get together for a new workshop on the future.
Okay, JC, thank you for your time. Thank you guys for watching this, and we'll be getting together when we get together.
See you all. Thank you. Thank you, Fede.
Bye bye.
Bye bye.